Okay, so we're gonna have you're gonna get a worksheet today that has a little graphing activity, okay? And I'm gonna do some notes for that in a minute, but first I'm gonna cover something that it's not gonna be on the homework today, but it will be something that is on the test coming up this week. So that is, you're not gonna use it today, but I want you to get it in your notes for right now. And that is horizontal tangents. Horizontal tangent. If you have a horizontal tangent, what's the slope of that line? What's the slope? The slope of a horizontal line is 0, right? So the slope at that point on the graph is 0. So the slope, which is f prime of x, equals 0. All right. So the only thing that we're adding here when we're dealing with horizontal tangents is that you find a derivative, you set it equal to 0. You can solve that for x to tell you where that horizontal tangent was, where that is on the function. Okay. So let's say we have f of x equals x squared minus 7x plus 4. Alright, and we want to know where this has a horizontal tangent. Well, can anybody look at this and tell me how many horizontal tangents it's going to have?
2.
Why would it be 2?
Because it's squared.
Okay, what shape is this? It's a parabola. How many times is the slope going to flatten out? Once. Okay? Alright, so you don't go by the exponent. You go by, you would go by maybe the exponent of the derivative sometimes, okay? But don't just look at the exponent for this stuff, okay? So, it's a parabola. That means the slope is going to flatten out once at the minimum or maximum of that parabola. That's the only time the slope is going to flatten out, right? So we want to find out where that is. So we do the derivative. F prime of x is 2x minus 7. We set that equal to 0, and we solve that for x. So 2x equals 7, x equals 7 halves. So at x equals 7 halves, that tells you where this function has a horizontal tangent. But this is also, I don't know how many of you guys remember in Algebra 2 finding the vertex of a parabola. This is a much faster way to find the vertex of a parabola than the way you learn in Algebra 2. So, because where this has a horizontal tangent, that has to be the vertex of the parabola, right?
So set the derivative equals 0.
Set the derivative equals 0. Solve for x. That tells you where there's a horizontal tangent. Okay? Now, it might not be a parabola. If you have a cubic function, that's probably going to have 2 horizontal tangents. All right? And so you might have to do some factoring there on the derivative. Okay? So let me do an example of that really quick. Let's say we have f of x is equal to, let's say 1/3 x cubed
Plus 17x. Plus 3x.
5 halves x squared plus 6x plus 10. Okay? So in this case now, if we want to know where the horizontal tangents are, we still do the derivative. Right? So f prime of x equals what? That's going to be just x squared, right? Minus 5x plus 6. Okay? Now we got to set that equal to 0. So now we have a quadratic equal to 0, which means you have to factor it. Okay? So this one, you would get what adds up to positive 6, multiplies to positive 6, adds up to negative 5, minus 2, minus 3, right? So x equals 2, x equals 3, those are where you have horizontal tangent. Where this original function, this cubic function, that's at x equals 2 and x equals 3, that cubic function has its horizontal tangent. Also tells you that there are maxes or mins there. Okay? Yeah.
So is the exponent minus 1? Is that what you have?
If it's a regular polynomial, then yeah. But we've got other stuff. We've got sines, we've got cosines, we've got rational functions. So if it's just a regular polynomial, then yeah, that's how many answers you would get. Pretty sure. Okay. Now, that's it for horizontal tangents. Okay, it's pretty straightforward. Set the derivative equal to 0. So now let's do what we're going to do today, which is graphs of derivatives.
Oh, graphs.
Do graphs make sense?
Yeah,